Hey, hello, welcome to the show. It is me, JP, and it is time for JP's product pick of the week. Thank you so much for stopping by today. We have a pretty snazzy, I think, product pick today to show off. And the first thing I'll do is send you over to the URL. If you want to go check it out, then go to that QR code, go to that URL. This show is broadcast from inside of the page there, and you will see we've got a big discount. We had 100 stashed. Thank you to Travis and New Products team for taking care of all of that so that we can offer this to you without any need for a coupon code or anything like that. Just go, pick some up, throw them in your cart, and off you go. They'll be half priced until the end of the show or until they sell out. So go take a look at that. As is custom here on the Product Pick Show, I like to thank everyone for stopping by. It's all about community, so thank you for stopping by over in our YouTube chat. Over there we've got Robert Cochran. Hello. Says it's a cool day here in the mid-Atlantic part of the U.S. It's raining here in Southern California. LA is getting rain, which is weird and freaky. Dave Odessa, hello. Hey there to Ken Wena and Batagraf of Dalhagen. Tyrone Mix, hello. And then if you're wondering where the chat is at, if you're somewhere else, if you're over in Facebook land or somewhere like that and the chat seems pretty empty, can't keep track of all of them, so encourage you to go right over here to our Discord server. You can get there by going to adafruit.it/discord. That's our URL shortener. And then from there you get an instant invite to our great big happy Discord server, and the live broadcast chat channel right there is where people are hanging out during the chats. Hello to Thin Man and Jim Hendrickson and C. Grover and Blitz City DIY. Hi. Special thanks to Liz for putting together the guide for this week's product pick, as well as the super cool example project that I will show you a modified version of that for a little demo. So without further ado, let me have Lady Ada tell you about this product pick from her new segment on Ask an Engineer. So take it away, Lady Ada.
Is the AS5600 sensor. This is from AMS. Somebody sent this over and said, this is a pretty nice little sensor because it actually, like the I2C, spits out the angle that it detects of a magnet. So normally people have a potentiometer, right? And you can twist it and it can measure like 0 to 270 degrees. Or you can have a rotary encoder, which only has 24 spots, but it can go all the way around. Well, what's nice about this sensor is when you pair it with a magnet, and magnet, you have the north and south be the knob of that's how it's detected. It will convert it to an absolute angle between 0 and 360 with like 0.4 degree accuracy and 0.1 degree precision. So you kind of get the best of both worlds. You don't have the mechanical wear of a potentiometer or a rotary encoder. You don't get only 24 dots per rotation. You get like 360 degrees. It goes all the way around, and it can keep track of absolute position. Like rotary encoders, they only tell you if you move left or right. They don't tell you if like where you are in the rotation. But what's nice about this sensor, you see there's a magnet behind it. It detects what the angle of the magnet is, and you can put the magnet on top or behind, either one.
Remember my mute button. Yeah, that right there is the product pick of the week this week. It is the AS5600 magnetic rotation sensor breakout. This runs over I2C, so you can just use the little stemma QT port there if you want, or you can use the pins on the bottom. And this gives us 12-bit analog output, that's the measurement, and then that goes out over I2C to your microcontroller. But 12-bit accuracy on angular positioning of a magnetic North Pole object. So you can use a little magnet embedded into a knob, which is the usual use for these, is a sort of frictionless, non-mechanical coupling to tell when a knob is rotating. This thing can tell. and it will sense the magnet from about up to 3 millimeters away from the surface of the chip, so you don't have to be right there. And you've got that absolute positioning, so it knows exactly where it's rotated within the 360 degrees with decimal 0.4 accuracy. And it can also tell the direction it's going, so it knows if it's heading sort of clockwise or counterclockwise. And it is, what else to say about it? Yeah, you can use it with either sort of a regular small magnet that you can flip so that you get north and south poles sort of above the sensor there. In fact, let me show you speaking of the sensor, let me show you right there. So that main chip right in the middle there. So you can set sort of our normal little coin-sized magnet on its end and rotate it, which is what was going on in that little demo video. Or you can use these really cool diametric magnetized on-axis magnets, which I had no idea existed. I have a little pack of them here that I got from DigiKey. Liz told me about these, and these are, unlike your typical like north is on top and south is on bottom, these are two half circles that have, you won't be able to tell anything with me showing it to you, but imagine the left half of this is north and the right half of this is south on that circle. So it's a little circle that's been cut in half, which is something you don't usually see with this type of magnet, is the ability for them to stick north to south, north to south, north to south on end, which is pretty weird, pretty wild. So if you're careful, you can still get them to stack on end, but they kind of have to rotate properly. So that little new fact to me, we'll put a little note in the guide about those. I think Liz might have one in her project guide for this endless encoder. So let's see, let's get to a couple little other facts about it. You can see here we've got mounting holes on it, so you can mount it to your swirly gig or 3D printed project. At the bottom there we have V in, 3 volt, ground, serial clock, serial data if you want to use I2C through those pins. Output is a PWM, so you can get a PWM value out of that. And then you've got the 2 stemma QT cables on the sides if you want to use those. On the bottom you'll see there are jumpers that you can jump to turn off the LED, so you don't see a little LED glowing on the front. You can jump to change the direction, which you could also do in code, so for most uses I don't think you'll change that, but that just decides if this is a counterclockwise or clockwise or counting up or down. There's a programming pin on there labeled PGO, which is for very advanced reprogramming of the chip. And the nice thing is that the chip does all the hard work for you and just outputs the answer you want, which is this 12-bit value that represents 0 to 4098, which we can then just use some simple math in our code to derive an angle. This is just over one I2C address, so 0x36, that is the I2C address. If you needed to use multiple of these in a project on a single microcontroller, you may have 2 I2C buses on some chips, or you can use an I2C multiplexer in order to read a bunch of them in sequence. What else to say? Let me show a little demo, then we'll look at the product page and data sheet and a couple other little things. So let's jump to this down camera right here. Let me make myself a little smaller in the corner there. And I'm just going to fix the focus. And you know what, I'll drop the brightness just so that isn't blown out, and drop the exposure. There we go. All right, so what we've got here, you can see I've got the A5600. I've got the A5600 mounted right here underneath a little 3D printed magnet holder / knob with a little print-in-place bearing that Liz designed. Super cool. And as the magnet, which is just, you can see it shining in there, a little green light next to it, as that magnet, which is sort of hovering above the chip there, rotates as I twist this knob, then it's able to measure that angular rotation. So if I bring this all the way back to 0, you'll see the raw value in the upper left there, which is that 0 to 4098. Here we go. I've got that little math turning that into degrees. And then I'm also counting revolutions. So you can see here, as I rotate this up, we're going up to 180, 270, 360. The raw value is going to flip back to 0. The degrees are going to flip back to 0, but the revolutions I have there just counting. So you can see if we spin, spin, spin this, we're able actually to just count how many times we've gone around. And we can undo all that as we spin backwards here. And you could use a heavier knob here to get a little more long-term spin after you let go, or a little ball bearing or something like that. There's a lot of ways you could use that. But it's a really nice, easy sort of jog controller. You could put a little divot in there and use that as like a video jog controller. This one works best just spinning it from the outside there. So let's take a look at product page here. You can see, let me refresh that. So those are $2.98. We have them in stock, which means we have over 100 of them right now. And you'll see that in the product page, there's also a note here. You can include a high-strength rare earth magnet. I'll let you know, this is the sort of more normal small cylinder with a north on top, south on bottom. So you'll need to turn that sideways, mount that in your knob, sort of on end like that, or go look for one of these diametric magnetized on-axis magnets. So here you can see we've got a couple of links to guides here. There's a primary guide, and in the primary guide you'll get the main info, you'll get the pinout. We have code for using this in Arduino and in CircuitPython, a little setup there, easy to use libraries. You can also use it in Whippersnapper. And then on the downloads page, you'll see we've got a link here to the data sheet. So this is the AS5600 12-bit programmable contactless potentiometer. I always like to see what this is meant to be used for. They say right out the gate here, it's an easy-to-program magnetic rotary position sensor. Contactless system measures absolute angle of a diametric magnetized on-axis magnet designed for contactless potentiometer applications, and its robust design eliminates the influence of any homogeneous external stray magnetic fields. Down here you'll see there's a little marketing info about benefits on this. You can also do some setting it more like a potentiometer to say it'll only go count values from 0 to 18 or 0 to 360 degrees. You can adjust the range. And I think you can also check the magnitude of it, which I didn't find a need for, but I suppose if you wanted to build like a little springy push button to emulate a push encoder, you could have a threshold there for how close the magnet gets to the surface of the chip. And then if you take a look here, this is what I based my little demo on, is this project that Liz put together. She has it acting as a consumer control HID volume control, which work on iOS, Mac, Windows, Linux, Android, anything you plug that into that uses HID volume control. This will act as a nice volume controller. So there's a little code in there, some 3D printing, assembly. You can check all that out there. And then I thought we'd take a look at the code I'm running just on, actually, let's take a look at a real simple example here first. So you can see, let me bring up my code window. Setup is really easy. We've imported boards that we can set the board I2C to stemma I2C. Imported the Adafruit AS5600 library. And then we instantiate this sensor as Adafruit 5600 over I2C. In the main loop, we set this angle variable to be equal to, just ask the sensor, what's your angle? Sensor.angle. That returns this 0 to 4098 value, 12-bit value, which we can then create a little degrees from by saying degrees variable equals the angle, whatever we just read, divided by 4096 times 360, and that gives us the typical 0 to 360 degrees we're used to. You'll notice one thing here. If I let me go ahead and make a new tab down here. Whoops, at the bottom. and go to the REPL, you'll see I'm actually showing the degrees with a decimal point of accuracy here. So I didn't want to show that on the display here just because it made the display kind of flickery. But if you look on, let me see if I can zoom this up a bit. If you look at the numbers on the bottom there, we've got the raw value and then the degrees. It's actually showing tenths of a degree here as I've got it set currently, and then it counts up those revolutions. Code I'm running on here is a little different than that simple code, but all you need to really know how to do is say sensor.angle, ask for that, and you'll get everything you need from this. My code just sets this up with a couple of extra things for determining when we pass the threshold going backwards to count down those revolutions, and doing some display I/O and terminal font onto the screen of this little TFT feather. So there you go. Super easy to use, no contact, non-mechanical, will never wear out other than the bearing of whatever this knob is on top. And I actually used a little bit of lubricant on that with the 3D printed PLA parts. You don't need it, but it made it, I think, rotate a little smoother. I just used some synthetic oil in there so this would spin nice and easy there. So let's see, any questions in the chats? Doesn't look like it. No. Okay. So that's going to do it. Let me wrap this up here and remind you, if you want to go pick one up, head over to that URL right there. And those will be on sale until a little bit after the show. But you'll want to wrap that up, place an order if you want to get some of these. So that right there is my product pick of the week this week. It is the AS5600 Magnetic Rotation Angle Sensor. For Adafruit Industries, I'm John Park. This has been JP's product pick of the week. Bye-bye. Chivit, chivit.